Hello again. So this is going to be a really quick video of how to get to the payload of the FatalRAT malware. I have this malware loaded here into Ghidra and I am at the entry point. So without going too deeply into all of this static analysis I did, you can just from the entry scroll down and you will see the standard stuff which you can find in an executable, in a Win32 executable come up, and eventually you get to the point where a variable is set to the return value of a function, and this variable is going to be returned. So this prompted me to check out this function here, which is the main, or which I eventually found to be the main, and I annotated it right away, called it main routine. So this is going to be the main. If we jump in here, we can see that there are these strings in here of functions: sh get special photo path a, and then the string here svp7.png. A couple of functions are loaded. First one, this sh special photo path a, and this is something I should maybe talk about real quick. The function address is retrieved here by get process address, and it's going to be the address of this function, and it's going to be called down here. But as you can see, there are no parameters here. This is something that happens pretty often, that the decompiler gives you something like this, and at that point you have to check out the disassembly listing. And this is here, where you can see that the call is being made down here to function address, and up here the parameters are pushed. This parameter 2e is the CSIDL. I annotated this here, made a little comment for myself. This 2e corresponds to CSIDL common documents, and if you run this malware, do a dynamic analysis, you can see that the path that is retrieved here is C users public documents. And this is going to be where this svp7.png is going to be dropped to. This path file exists, checks if this svp7.png already exists, and eventually you will come down here to this, what I call susd code, and it gets the string, this svp7.png, as an argument. Now, this is what contains the payload. So, in the susd code, when you come in here, you can see that first a file is created. Create file is also used to open files. So this svp7 is opened, and the file size is retrieved and stored in this DW size. Next, there is the virtual alloc, which is always interesting, that allocates us this buffer. And the read file function then takes the file and reads its contents into buffer here. And then it just closes it. Now comes the interesting part. And this interesting part is here in the while loop, because up here we get a pointer to the buffer, and then it goes through the buffer byte by byte and performs this little, let's call it deobfuscation or decryption, where you can see that the buffer pointer is dereferenced. So this is going to be 1 byte, and then it's going to be XORed with hexadecimal 3D, and then hexadecimal 3D is going to be added in the end. And then the pointer is just incremented. And of course, the result of this operation is written back. Now there's a function down here, which I called alloc. And this alloc here contains some further loading of functions. I don't want to get into this specifically, because I just want to show you how to get to the payload. So the last thing that happens is this virtual free, where this buffer that contains the decrypted file contents is freed. Okay, so I'm here on my Windows 10 machine, and I have the sample here. It's already on the desktop here, and we are just going to throw this into x32 debug and then have a look at it. All right, I will just go ahead real quick and make this a little bit larger. And we're also going to go in dark mode because we want this to look cool. And then we're going to set a breakpoint at virtual free and just check out what happens. Of course, there's also the option to set a breakpoint at virtual alloc, which we're also going to do. And then we're going to run this. And we reach the entry point. And you can see down here that we just reached the entry breakpoint, which is always a breakpoint. So we can just skip over that. And here we are at virtual alloc. Now I'm going to execute until return. That's this button here. And here we are at the return. So now we're going to step once. And as you can see, we called virtual alloc. Now the return value of virtual alloc is going to be an EAX, and this is going to be a pointer, a void pointer to the allocated buffer. So here we can see in EAX there is this value, and if we just right click and say follow and dump, we are here at our newly allocated buffer. So before we come down to this virtual free, let's set a breakpoint here so we can watch what happens to this memory area. And I'm just going to say breakpoint, hardware access, and then byte. This is the virtual free, the call to virtual free. I'm actually going to set a breakpoint here so we don't jump into virtual free, or if something goes wrong, we have this breakpoint so we don't have to restart everything. All right, let's run here. And as you can see here, this is what has been loaded to the memory area. And here we are in the routine that does this XOR with 3D and also this addition with 3D. So this is the interesting part. We're gonna get a couple of breakpoints here because this runs a lot of times for every byte here. So we're just gonna go run again. And as we set the breakpoint only on the first byte, we didn't get that many breakpoints after all. But as you can see, we have here MZ, and then this program cannot be, just make this a little bit larger, this program cannot be run in DOS mode. So here is the executable. There's already some human readable strings in here. If we just scroll down in here, yeah, you can see here already get version, terminate thread, get system info. And I'd say we just continue running this and till we hit the point virtual free. And now we are at virtual free. So this is going to be freed in the next step. Before that happens, we're going to dump this area in memory. So we're going to do a right click here, and then we say follow memory map. Here we are at the memory location, and then we're just going to say dump memory to file. And I'm just going to rename this. So the file name is a little bit shorter, and we're going to call it FatalRAT. And I have to dump it again because I didn't see where it's actually going. So here we're going to say FatalRAT. And then we should have the payload. So let's throw this into Detected Easy and have a look at it. That looks good. Okay, let's see if we can get any imports. All right, we have some imports. That's cool. And maybe have a look at the strings again, because I saw something that was quite interesting before when I just ran over it real quick. So here are a lot of functions. Here's something, VMware, virtual machine guests. That's already pretty interesting. Create tool, help 32 snapshots. Okay. And then we have these. This indicates that there is a keylogger inside of this binary, or that is one function of the RAT. This is also interesting with this .exe and so on and so forth. You have Skype, Chrome. Okay. So this looks pretty good, I'd say, at least at a first glance, and I think we were successful in dumping this. Oh, look at that. There's some names of antivirus programs. Okay, so I think this looks pretty good. And we can just save this and then continue with the analysis here. I just imported this this binary that we dumped into Ghidra. And I'm here. I just went ahead and went to the symbol tree, and under user 32DLL, I went to this get asynchronous key state, as this is a function that may be used to realize a keylogger. I just followed it here, and this looks pretty good. The disassembly looks very nice. So Ghidra didn't even give any errors here at this point. So I think dumping the payload was successful. And in the next step, I am going to work my way through this and just check out the features of this malware. And of course, now that you know how to dump the payload, you can do the same. So if I find anything of interest here, I might do another video on this. But for now, my goal is reached. I showed you how you can dump the payload. And with that being said, I'm gonna end the video here. So if you came this far, thank you very much for watching, as always, and I will see you around. Goodbye.